Joseph Louis Gay Lussac was a French chemist and physicist that discovered the law of combining volumes of gases by observing gases at constant temperature and pressure. He observed that hydrogen and oxygen combine in a 2-to-1 ratio, 200 volumes of hydrogen for every 100 volumes of oxygen, to form water. He also saw that hydrogen, chloride, and ammonium combine in a 1-to-1 ratio by volume. This led to Gay-Lussac's law that gases at a constant temperature and pressure combine in numerical proportions by volume, and the product also has a simple proportion by volume to the volume of the reactants.
In Gay-Lussac's law, a gas's pressure is directly proportional to temperature as long as there is a constant volume and number of moles. In this equation, the capital P represents pressure, the symbol represents directly proportional to, and the capital T represents temperature. Another way this relationship can be represented is through this equation, where P1 over T1 represents the relationship between the initial pressure and initial temperature, while P2 and T2 represent the final pressure and final temperature. According to this law, both sides of the equation should be equal. Now it's your turn. If you are given a gas which has an initial pressure of 500 and an initial temperature of 600, what is the final temperature if the final pressure is 200? You have 10 seconds.
For this experiment, using lit matches, we used heat to make air molecules push an egg into a glass bottle. Make sure you use a bottle so that the egg can sit on the opening of it and not fall in. To start, you are going to light 3 matches at once and quickly drop them into a bottle before setting the egg on the mouth of the bottle. The egg should then get sucked into the bottle due to the lower air pressure that is created within the bottle. For this next experiment, we made a can implode using heat and ice water. Heat a can that has a small amount of water within it. Once smoke starts to escape the can from the top, using tongs, take the can off the hot plate and turn it upside down before submerging the can into ice water. Once in the water, the can should compress as the water vapor within the can cools down and it condenses into water droplets. For the last experiment, we made a cork pop off an Erlenmeyer flask using baking soda and vinegar. First, scoop a decent amount of baking soda into the flask. Next, pour some vinegar into the beaker and pour that into the flask, making sure to quickly put the cork on the flask after the vinegar is poured. When the baking soda and vinegar react, it causes a buildup of pressure in the flask, which is why the cork pops off.